This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
This week we have Jeff Pierce, who is at IBM Almaden Research, recently having come there from Georgia Tech, where he was on the faculty. And what he's describing here is mostly the work that he started at Georgia Tech and did there, which is in a vein that some of you have seen actually here, because we did work on things like the iRoom, which basically were in this general area of how do you work in an environment where you have multiple devices that you want to coordinate. It's not just the computer and it's not just the network. And Jeff took a different direction on that and has done a lot of work on sort of integrated information environments with multiple devices.
So good afternoon, everyone. Like Terry said, this is actually going to be primarily stuff from my years at Georgia Tech. The stuff I've been doing at IBM Research is what I'm sort of pushing on now, but since it's fairly recent and I haven't filed the invention disclosures yet, I can't talk about it too much in public. But I'll show a picture near the end that'll give you an idea of some of the stuff that I'm pushing on. So what I'm going to focus on today is this notion of moving from this model of a personal computer to the model of working within a personal information environment. And so the model we really have of interacting with the computer now is this notion of a user sitting down and working with their single personal computer. Okay, and the underlying assumption that sort of followed here is that computers are expensive. So you have one and you're grateful. And why would you ever want more than one? One computer should be all you really need. Common incarnations we see these days, obviously the desktop and the laptop. The range for these things, we'll be a little generous. The 80s up until the present. Okay, is there anybody here who doesn't have a personal computer? Speak up now and they'll kick you out. But the observation that I made a number of years ago, and this isn't just me, other people have made too, is that people are shifting from this model of working with a single device to actually interacting with multiple heterogeneous devices. So, laptops, desktops, cell phones, PDAs, tablets, iPods, game systems, all these things are computers, all of them are yours, none of them really knows that you have other devices, okay? The underlying assumption here is actually that computers are cheap, and they're getting cheaper all the time, okay? My favorite example of a cheap, widely deployed computer is actually the chip in your anti-lock brakes. Think about that the next time you worry about hardware system crashes. Okay. So, to give you some examples, actually, when I was still at Georgia Tech last summer, I took my camera and I wandered around. I took some pictures of sort of these first steps toward personal information environments. And so if you look at these, all these are sort of the form. We have a desktop with a laptop by the side. Okay? Even if when you have multiple displays, you'll often find people sticking the laptop by their side. Okay? And just to give you a feeling, I actually didn't have to work that hard to take these pictures. I wandered around for 15 minutes over 2 floors of our building, and this was over the summer, so most people were already gone. I actually really like the one down in the corner. These are actually some folks in the robotics lab, and what they're doing is they are using simultaneously a desktop and a laptop, and some of them want to use both devices so much that despite the fact there's no space to put on the desktop, they have their laptops in their lap. So they're working here, and then they're working here, and then they're working here, which I would find uncomfortable, but I guess they really want to use those 2 devices. This is actually what my office used to look like. So I used to have a PowerBook, and then a Windows machine, and then this was actually a tablet PC. So I usually had at least 3 devices that I was working with at any given point in time. That's not even counting my cell phone in my pocket and my desktop at home. Okay, so I'm always curious to see how these things change too. So I have a quick informal survey. I want you to count up the number of devices that you own or that you don't own but work with regularly. Okay, faculty, it's not fair to count all the computers in your lab. That's cheating. But grad students, you can count up the computers you use in the lab plus your personal devices. Okay, it includes cell phones, include PDAs, don't include your anti-lock brakes. Okay, how many people have at least 1 device? 2 devices?
iPods count?
iPods can count too. 3 devices? 4 devices? 5 devices? 6 devices? 7 devices? 8 devices? We'll stop counting. We don't know how long we want here. Okay, so we actually did an informal survey back at Georgia Tech, and this was, you guys are skewed. Most of you, I assume, are computer scientists. You guys tend to have more devices, but just a bunch of average students at Georgia Tech, turns out it's about 4.7 on average. Okay, so we're not completely making this up, talking about the future. This is actually what people are doing now. Okay, so what do we talk about as the ingredients of a personal information environment? So Terry mentioned that some of this work was in sort of the same vein as the iRoom. One of the key differences is that the iRoom and a lot of the interactive workspaces projects have focused on augmenting spaces. So how do you augment a conference room so people can work with a lot of devices there, or how do you augment a classroom? The focus we took was focusing on the individual user. Okay, so you as a user have lots of devices that you own and work with. How do we help stitch those devices together? Okay, so this includes things like your personal devices. The first row is sort of this stuff now. Eventually you can imagine this extending to your car or your house. You can also then talk about public or semi-public devices. So things in a conference room count as sort of semi-public. Stanford owns them, presumably Stanford administers them. There are certain assumptions you can make about their capabilities and how safe they are, down to the PC at your local Kinko's, which odds are has been hacked fairly recently. Also things like desktop projectors, eventually walls and tables, some of the stuff, for example, at Merle and Diamond Space. Okay, so given that we're now working with multiple devices, what's the problem of applying this model of the single personal computer to this collection of devices? Okay. Well, right now, each of the devices assumes that it's your only one. Okay, there are a couple exceptions. Yes, you can sync your Palm with your desktop. But in most cases, each of your device has no idea that you have other devices, even if they're sitting next to each other. Okay. So you usually have to connect your devices yourself if you want to work across them. When I was at Georgia Tech, and actually this is still true, all of my devices use DHCP. And so whenever I wanted to connect one device to another, I was always having to fire off ipconfig to figure out what today's IP address was to initiate the connection between them. You have to authenticate manually. You have to manage your own information across devices. I used to make fun of my networking friends because we went from this age of SneakerNet, where the way you moved information between devices was you pulled out a disk and you put it in one device, and then you carried it over, you wearing your sneakers, to another device and plugged it in, to the internet will save us all, and it'll be the way we move information across all of our devices, back to SneakerNet. How many of you have a USB flash drive you use for transferring information between your devices? Yes. Even when I have my devices sitting next to each other, when I work at IBM, I usually have a Windows laptop and a Mac laptop right next to each other. The fastest way to move information between them is to pull out my gigabyte flash drive and manually transfer stuff back and forth. And then things like managing preferences as well. So you always have to set up your bookmarks the same on each of your devices and all that fun stuff as well. Okay. Plus, the interfaces that you work with are typically limited to a single device. Yes, there are some mechanisms we come up with for migrating them between devices, but there's really no notion of, I'm running this application, I want this window here and this window there. So there are a couple ways we came up with for describing this sort of work. One of the ones that I kind of like is interacting across multiple devices is like collaborating with yourself. You have to worry about things like availability. Instead of can I reach that person, it's can I reach that device. You have to worry about who has the right version of information, version control with yourself as the person you're managing it with. And all sorts of other fun aspects as well. You have to worry about, can this device do that? You have to worry about expertise. Okay, so opportunities and challenges. This is not a complete set. This is sort of what I'm going to focus on a little bit today. So if you recognize that people are now working across multiple devices, some of the opportunities we can think about are how do you improve access to the information across your devices? Okay, so you don't have to worry about which device has that copy of the file. How do you better leverage the input and output capabilities? Okay, can you do multiple monitors with two laptops sitting next to each other as opposed to a laptop plus an external display? And then challenge is, once you start lowering the barriers to interaction across devices, you introduce some really fun security and privacy risks. Okay, you have to think about how you balance those benefits with the potential risks. So the part I'm going to focus on today was some of our work looking at interaction with portable computers. Okay, and by this I primarily mean cell phones and PDAs. Yes, laptops are portable, but they're not portable to the same extent that a cell phone or a PDA is. So how many people have their laptop here with them? How many people have their cell phone here with them? Okay, usually pretty much everyone has their cell phone. Computer science audiences usually get like 75% have their laptops. The number goes down drastically if you get a bunch of business people in a room. Okay, so portable computers have the most limited I/O. Small devices, the most limited storage, most limited processing, but the thing that's most likely to be with you, and particularly in the case of cell phones, they're usually connected to a network. Okay. So, the particular opportunities we're going to focus on are a couple projects. One, looking at using your portable computer as an access point. So how do you use your cell phone to access and share information? And then how do you take advantage of nearby I/O resources to improve your interaction with your cell phone? Okay, so I'm going to talk about a project first called Seraphe, and then I'm going to talk about a project looking at this notion of opportunistic annexing of nearby devices. So when we started looking at portable computers as this access point into information, one of the things we were talking about was this notion of being able to easily share information. Okay, so there actually was a case, I guess a couple years ago now, where I was with Scott at a workshop at a conference, and I was talking about some work we were doing with adaptive interface, and it said, oh, we just came up with a paper on that, I should really send you a copy. And because that information was actually back on my desktop back at Georgia Tech, it had to wait until I got back there to be able to send him that information. But if I had my cell phone with him, I could have basically said, oh, let me send you a copy of that file. And I pull it out, and I find the information that I want, and then I send it to Scott, and I'm done. I no longer have to worry about trusting my memory, which back when I was an absent-minded professor was actually a big problem. I'm getting much better now, thank you. Okay, and the problems here obviously are the information is spread across devices. Right now, cell phones are not to the point where we can copy all your information there and declare victory. Devices can be inaccessible. So it turns out that most of the devices you probably work with have firewalls, and so you can't just open up arbitrary connections to them. And they often have IP addresses that change, unless you're at an old university and you have a large address space and you can afford to allocate one IP address per device. It also turns out that people turn things off. A lot of the database people I know doing peer-to-peer stuff say, well, we'll just assume devices are always on and connected. My mom always taught me to turn things off when I wasn't using them, which is a habit I've continued now that I'm paying my own electrical bills. And so you have to think about cases where you want to access information and that device is not currently accessible. The other part of this is that people are forgetful. Yes, in theory, I could remember that I wanted to send Scott that file, but as I get old and senile, that becomes problematic. So the solution we came up with was this first step toward a personal information environment. We provide the capability for all your devices to be aware of each other. Okay? And then we allow you to do things like initiate search queries across those devices, so you can ask for files matching some particular pattern. And you can then get the results back in your mobile device and then exchange that information with other people. So the trick we're playing is we're extending instant messaging. Instead of one IMID per user, we're essentially doing one IMID per device. So now instead of instant messaging being a mechanism for users to communicate, it's now a mechanism for users and devices to communicate. So to give you an idea of what this sort of might look like in a typical usage scenario. So we have a user who bumps into someone else and wants to send some information. And so she pulls out her cell phone and she says, oh, I want to send you that memo I wrote up. And she types in a quick query. That query goes out to her devices. They return results. She says, oh yeah, that's the one. Let me send it to you. And she punches in the other person's cell phone. And she's done. That other person then has their cell phone ring saying, oh, you've got an incoming file. And that person says, oh, well, I don't want to do it now to my cell phone. Why don't you send it to my desktop and I'll look at it later. And just email it to me. And then he's done. And then behind the scenes, those devices exchange that information and the file gets transferred. So to give a feel for a little bit what this looks like. Top left, sort of things you can do. So you have an inbox for messages you've received, either requests for files or information about file notifications, transfers. Since we're doing this on top of IM, you can send instant messages as well. You can initiate a file transfer. So you can do it to other users. You can also do it between your own devices. You can request a file as well. So if you're suddenly in a talk, you're like, oh, I really need to get that file from so-and-so so I can look at it on the train home. You can initiate a request for a file. And the view key part I'll mention a little bit later. It gets into how do you set this up so it's a little more secure. You can select who you want to share it with. You can send it to yourself. This is a way of sending information between your own devices. You can also send it to people that are offline. They don't have to necessarily be online to do this exchange. Because cell phone input is relatively painful, we try to come up with a couple of shortcuts to simplify the interaction you have to do. One of the ones we came up with was the idea of providing a quick access to recently sent files. And the idea being that files you've recently sent, you're likely to send again relatively soon. If you don't want to do that, you can enter search terms. So the version we built here, you can do a file name. You can specify a device or set of devices if you want to limit the search. And you can also specify file types. And you get back a list of results. The little pictures on the left-hand side there actually indicate the particular device that it comes from, since actually doing a name took up lots of space, as well as some additional information about the file name and also the size. And then you can select a file to make sure it's the one you want, and put in a possible message as well. So in case you're not face-to-face and want to explain when someone's getting a file out of the blue, you can put a quick message along with it. Oh, and speaking of shortcuts, here's the file was, it turns out a really handy, I always forget that in presentation mode, PowerPoint's keys work differently. Here's the file was actually a good, useful message to accompany it, because in most cases that expressed all you really needed to know. When you had a incoming message, so someone was sending you a file, you got a message saying you had an incoming file, information about who it was from and what that particular file was. You could then choose how you want it delivered. We actually supported 3 mechanisms. You could send it through email, you could send it through the instant messaging channel, or you could do a direct point-to-point FTP. And then you could choose which of your devices you wanted it sent to. So it didn't have to come to your cell phone. You could actually route it to any of your devices. And I mentioned you could do explicit file requests as well. Okay, this is useful not just when the user was someplace else. You can also use it yourself as a mechanism for essentially a little reminder. And of course, since this is IM, we could do the desktop interface as well. This was actually a case we were less interested in, but we sort of built this version 2 primarily for the cases where you're at your PC and someone requests a file from you, or someone's sending you a file and you're at your PC. So you can see available devices as well as users. Same sort of thing. We actually keep a list of recently sent files that's there before you initiate a search to try and shortcut the interaction. And you can put some information, and then you can choose when you get one of these requests how you want it delivered. A couple other extensions. So obviously, the interaction here is smoothest if both users are Serify users. So they're both using the system, but they don't have to be. You can actually choose, instead of sending a message to a particular, sending a file to a particular user, you can actually just send it via email and punch in the email address. And we did play with some simple mechanisms for selecting multiple recipients. Okay, not to the level of, I want to send a file to everyone in this audience, which is arguably a little more interesting and a little more complex, but being able to select subsets of available users. So we actually built this on top of instant messaging. We had initially talked about sort of leveraging one of the existing commercial systems, and then realized they might object if we violated their usage policies and had more than one ID per user, so we rolled our own quickly. Turns out some of the biggest extensions we had to make here was to handle cell phones, because you wanted to do things like if someone requested a file and you weren't currently online, you wanted to route that to the cell phone via an SMS message. And also things like when you got a message to a desktop computer or a laptop, it was easy to handle it right away. But because cell phone interaction was fairly painful, a lot of times people wanted to defer messages. So you essentially needed the mechanism to save IM messages for later handling. And we actually built 3 mechanisms for doing information exchange. FTP is sort of the best case point-to-point blast the files, but it runs into firewall issues if you can't accept an incoming file transfer. And so we built IM, which gets around the firewall issues, but places a burden on the server as an alternative, as well as just straight email. And obviously, I mentioned before that security is one of the issues here. The way we currently got around this was we essentially do a key per user. Okay, so you have an AES key, and you can basically do symmetric encryption. And so you can encrypt all your stuff, assuming that each of your devices is the only one that has that key. You can get both privacy and security by encrypting and decrypting the information that flows between devices. Okay, so that's a mechanism for accessing information across your devices and then sharing it with other users. But you can tell a story where, well, down the road, the increases in storage density being what they are, will eventually be able to carry all this stuff with you. I mean, you can get what's Apple up to these days? 60 gigs for an iPod? When you're carrying around 60 gigs, odds are that covers most of what you want to have or work with or share at any given point in time, unless you're doing a lot of movies. But the I/O of portable computers is going to be a problem for a little bit longer, because these things have to be small enough to fit into a pocket. Okay. I actually used to have a PDA that I used a lot, and I went to a cell phone, which I use a lot less. And the big reason was this is easier to fit in my pocket. Okay? And this is about the limit of what I'm willing to carry with me at all times. So, well, we could just say people will carry their laptops everywhere. I can wager you good money that's probably not going to happen. You could just give up and say, well, we'll just make do with the bad input we have now. Being an HCI person, that's not my first choice either. You can wait for new I/O. For example, Philips has been doing stuff with foldable displays and electronic paper. Maybe that'll save us all, and eventually you'll just unroll your display when you need to work with it. I think that'll actually be really nice, but it's a question of how long you're going to have to wait for it. Or if you make the observation that as we move about the world, we're encountering more and more often available I/O devices, you can think about how do you let users take advantage of them. So we came up with this notion of opportunistic annexing. There's been other names of it. People have talked about the notion of opportunistic augmentation. Some of Bill Schilt's ideas for device ensembles fit in here as well. But the basic idea is, how do you allow people to leverage nearby I/O resources to improve their interaction? Okay? So you can think about this notion of devices being capable versus devices being luggable. Portable is a less fun way to say that. I like the notion of luggability. Cell phones are very luggable, but not very capable, as contrasted with desktops, which are very capable, but not very luggable. Out of curiosity, how many of you are old enough to remember the Indigo 2 Extremes from Silicon Graphics? I love those computers because SGI built them as luggable. And they were luggable because they gave you a luggage rack along with the device. You could strap it onto and roll it around. Early portability for desktop computers. So the notion of opportunistic annexing is, how do you take devices and keep them just as luggable but shift their capability by taking advantage of nearby devices? Okay, so you can think about this for personal devices. You know, since I often work with two laptops next to each other, I can take advantage of the combination of those devices to do things like do multiple displays using two devices. Okay? You can also do things like take advantage of specialized I/O. So I have some artist friends who work with tablet PCs, and they'd love to be able to do something like work on the tablet and do close-up detailed work here using the stylus, but also be able to easily see the context in which they're working so they can assess the impact of the changes that they're making. I don't know if you guys work with tablets much, but their screens are still relatively small, which is one of the advantages. They're very portable. You can carry them to classes and take notes. But it makes it difficult to assess the impact of the work that you're doing. There are also privacy aspects here as well. You know, if you're working in a shared lab, for example, you may want to shift information to a smaller display where it's more private, and your coworkers can't see that you're really playing a game as opposed to getting work done. Not that would ever happen here, I'm sure. You can also talk about annexing devices in the environment. Okay? So how do you allow users to carry their cell phone around and, when they're wandering through an airport, taking advantage of a nearby large display to read their email? Okay? Key steps here, you have to have some way to connect devices. People have talked about a variety of mechanisms. You can do RFID and wave them near each other. You can do, people have talked about barcode scanners or icon recognition to pull out the addresses. Worst case, you can show the IP address, and phones are actually really good at putting in numbers, so you can just punch in an IP address that way. You have to describe the interface that you want to work with on the device, and then you have to interact. Okay? One of the questions people often ask here is, well, why don't you just transfer the interaction? Heck with, trying to augment your cell phone with this. Let's just presume this is a web service, and we'll use that public display, and we'll contact your information directly. Okay? Two issues. One is privacy. So if you're working on a large public display, people can see what you're doing. The other one is the issue of untrustworthy devices. Okay, so simple spitball example. We have Alice. This is a non-annexing example, by the way. So current real-world situation. Alice wants to check her email. She ducks into an internet cafe and she logs into Gmail. Okay? Simple, straightforward interaction. She can now access her email using that large desktop display. The problem is, first of all, that device can capture and reuse her password. So now whoever has put their keylogger on that machine can access your email anytime they want. In addition to capturing that information, even if you come up with a mechanism to bypass this, and people have done two-factor authentication where you get one of the key fobs and you get the fixed ID of your password plus some changing ID. Once you've logged in, once you get past authentication, that device can now access all your stored email. Okay, it can sit there and basically tell Gmail that it wants copies of all your messages without you realizing it. It can modify messages before you see them or before you send them. It can capture your contacts. And it can even send email pretending to be you. So when you log into that device, behind the scenes, it can send email to georgebush@whitehouse.gov saying, I'm a terrorist, here's my email address, please come get me. Okay? So, how do you deal with untrustworthy devices? Current mechanisms are essentially all or nothing. You either don't use the device, or you use the device and run the risk. Statistically speaking, what are the odds of this computer being hacked? Well, right now it's probably relatively low, and so I'll go ahead and run the risk because it's just my email. Okay? But these things are changing as hacking computers becomes more of a business and less of something that people do for fun and games. Okay? So a better solution, we argued, was take advantage of the personal devices you have with you. If you're already carrying your cell phone, why don't we take advantage of that as a private personal input and output mechanism? It's more likely to be trustworthy, modulo whatever operating system you're running on it. And then you can divide the interaction between the public and the private display. You can put sensitive stuff, both information and also interaction, on the personal device, and you can put information that's not so sensitive or you don't care about people capturing on the public device. Okay, and you allow users to choose how much they want to trust those devices. So we thought that sounded great in theory. We decided to actually do a little study and find out, if we built it, would people actually care? Would you want to be able to divide information across devices? So we grabbed 18 people, 13 men, 5 women, a variety of age ranges. You can tell we did this at a university because you have grad students up to younger faculty. Though we actually did get professionals as well. And we asked them to do a couple of tasks. To think about how they would do an email task where they had to check their inbox and read some messages and then forward some flight information along with a brief message to a colleague who was going to pick them up at the airport. Access their calendar, so they wanted to view their daily schedule to find an appointment and then add a doctor's appointment. And 2 more. Do a spreadsheet as if they were doing an expense report, either for business or if you're a grad student getting reimbursed for a conference you just been to. And then doing an online purchase. You're going to London, you want to get some Tower of London tickets, and so you had to choose the ones you wanted and then enter your credit card information. And we asked people to think about doing this in 3 different environments. So we asked them to talk about doing it in a public environment, which was the lobby of a building, a semi-public environment, which was a shared lab where other people could see what you were doing, and then a private environment that was an office that had a door you could close. Okay? And we asked them to think about being able to use 3 different devices and divide interfaces across them. A mobile phone, a desktop, and then a large projected display. And because this was an exploratory study, we didn't actually have to build the infrastructure. What we did is we made lots of copies of interfaces for a large display, a desktop, and a cell phone, and we cut them up into little pieces. And we put Post-it glue on the back. And we asked people to take these components and describe how they would want to interact. Okay, so you had a large display where you could put information, you had the desktop display, and then you had the cell phone. And you would pick out the pieces that you wanted and describe what you wanted on the desktop and what you wanted on the mobile phone. Not only could you do components, you could actually do some behavior and content changes as well. So for example, if you wanted to display information in your calendar on the desktop, you could actually replace the details with just information showing it was busy. Study method, which I feel legally obligated to mention. So we did counterbalance the presentation of the environments across users. We did randomize the task order. We did this as a talk-aloud protocol. So we wanted to find out not just what people were doing it, but why they were doing it. So what was their thought process when they chose certain divisions? And we captured all the sessions since we can't write that fast. And we looked at what people did and why they did it. My standard exploratory interface disclaimer. This stuff is all exploratory. Okay? People actually couldn't do this interaction. They were talking about what they might want to do as opposed to what they were actually doing. So real practices may differ. Take these results with the obvious grain of salt. But they do motivate directions for future research. Okay? Concerns that people have in this initial situation is likely to be the sort of things they will care about in a real environment. Okay, high-level results. People were interested in dividing. Okay? 17 out of 18 people divided at least once. One person said, this is way too much work, I know, I just want to use the desktop and declare victory. 14 people divided in over half of the situations. Okay, so both environments and tasks. People were much more concerned about other people than about devices. 15 people worried about the onlookers and what they might see, while only 6 people worried about the devices. Okay. The divisions varied both by user and by environment, but there were some commonalities within users. Okay. So people are idiosyncratic, but they're not that idiosyncratic. And then the choices by environment largely matched what we expected people to do. Okay, so in private environments, they did things like, I want to see my inbox on the large display for my context, and I want to see a particular message on my desktop. And they also wanted to move information around to avoid clutter. If there were a lot of windows open, they wanted to shift some of the windows to different displays so they could see them all at once as opposed to tapping between them. Semi-private environments, people thought about, I want to make some information private, but I also want to share some information. So for example, in the case where you want to buy tickets to the Tower of London, people talked about being able to put that web page up on the large display so that other people could see they were going to London and drop by and share experiences or make comments. Okay. And then in the public environment, you still saw stuff to improve the user interface, but then you saw things about addressing the privacy and security concerns. Okay. People did think about what the devices might do to some extent, but even more about what other people might see. Some more detailed stuff. People actually did divisions both for component allocation, for component content, and for component behavior. Moving the particular components around, the allocation was the most common one. Next most common was content, and the last was behaviors. We were actually a little bit surprised that people talked about behaviors because we didn't stress that much. We mentioned it as a possibility, but it's hard to describe behaviors in little pieces of paper. But people on their own talked about different behaviors they might want to have on different divisions. And we also saw this in all environments as well. So we kind of expected we'd see a lot of this in the public environment, and we did, 17 out of 18. But we actually saw a lot of division in the private environment as well. Okay, people wanted to take advantage of the devices that were available. Reasons for dividing. Entering lots of text was a big one. So if I'm going to put in lots of information, I want to take advantage of the best device for the task. Similarly, if you're going to view lots of images and lots of text, you want to split that stuff out so you can see more of it at once. One of the ones that amuses me is mobile phone people hate the notion of scrolling. And actually, it's not just mobile phone people. I've seen some results for desktop as well. If it's below the fold, people won't scroll, they give up. But they passionately hate it on mobile phones. Not just vertical scrolling, but it turns out if you make people do horizontal scrolling, not only do they give up, but they send hate mail to you and your families. If you make them scroll this way, they get really cranky. And then privacy as well. So again, on the workers, people were more concerned about the devices. And then sharing, 7 out of 18. And this notion of monitoring, for example. I want to be able to monitor my inbox. So I'm going to push it off to the large display so I can glance at it occasionally to see if I had new mail. Sort of an ambient display type usage. Okay. The one we were kind of curious about, since we thought about this notion of untrustworthy devices, and how could you put that information on the public display? That's unsafe. So we decided to push on this one a little bit more. So what we did was a follow-up online questionnaire. Okay, we asked people about accessing their email, their calendar, and then purchasing items. Okay, focusing on just 3 tasks now. We asked people up front to list risks they perceived and then rate the severity of them. And then we followed up with some risks that we came up with. So this was sort of see what people think about on their own, and then see how they feel about the risks we think are actually the ones they should be caring about. We've got 28 users. We got a wider age range this time, 20s through 60s. 6 of them were students, but 22 were professionals. Obligatory pretty picture. The thing to take away from this is the more yellow it is, the less people are concerned. The more red it is, the more they're concerned. Okay, so on a scale of 1 to 5, where 1 is, what risk? There's no risk. And 5 is, oh my God, I must never do this. The average across all this was 2.5. So people sort of fall in the, maybe. It doesn't seem like it really concerns me that much. The thing about this that I find really interesting is this is actually sorted based on age. So the folks at the bottom that are 20 to 29 basically see the world as a happy, fun place where there are no risks. And the people who are in their 50s and 60s view computers as strange, dangerous things where lots of malicious things can happen. I'm actually curious about this. I'd like the chance to push on this a little bit more. I have 2 competing theories. One theory is the older people are more experienced and realize the world is not a happy-go-lucky fun place. The other theory is that, 3 theories. Second theory is that old people don't trust computers anyway, and so this is just one more risk. The third theory is that old people have more money, so they have more to lose if something bad happens. But we weren't looking for this effect. This actually came out of the results, so I don't actually have any explanation for why we saw this yet.
You also got that one guy at the top
It's all bad. The other thing about this is, so notice that people are less concerned about email, they're more concerned about their calendar, and they're really concerned as soon as you mention credit cards. Because the media has trained you that you have to be careful with your credit cards. So what lessons did we draw from this? People were interested in dividing, so this was sort of, okay, we should push on this more. If you offer people choices for dividing their interfaces, you should allow them these 3 separate mechanisms. So affecting the allocation of components, affecting the content of the components, and affecting the behaviors. When dividing, because we saw sort of this controlled idiosyncrasy, provide people some common choices we saw a lot, but let them modify them based on their own personal preferences. And then since people aren't thinking about the risk of using untrustworthy devices, there's this interesting question of how do you communicate both the risks of the choices and the effects of the choices? What can go wrong and what has gone wrong or is going wrong. Other stuff we saw, just to mention on the side, people liked the notion of being able to divide interfaces across devices, but they didn't want to switch their focus of attention much. Okay? So when they divided it was, I want to do this part of the task here. When I finish that part of the task, I want to do this part of the task here. I don't want to be bouncing back and forth a lot. Okay? Although people did want to divide, they also wanted simple mechanisms for moving content from here to here. So they didn't always want to divide. In some cases, they said, I want this here, and then I want to move this over here. Okay? As well as mirroring. We saw people who requested, I want to see the same thing in both places. Okay? And the last one is that people are going to trust their devices too much. And so you have to think about, when they're working with untrustworthy devices, how to essentially have your users' backs. And so being computer scientists who like to build stuff, we actually started working on a framework and then an architecture to actually be able to build some of these divisible devices. And the requirements we came up with were, the primary ones, allows users to affect those different types of allocations. So where do the components go, what the content is, how they behave. And then providing this notion of translucency. So I harken back to Ronald Reagan, who, when do you guys remember when Ronald Reagan was president? I used to do virtual reality research, and one of the demos we had was you could step into the Millennium Falcon from Star Wars and play Luke Skywalker training the lightsaber. And I still remember the first time we had some undergraduates come in for a demo, and we said, "You guys all remember Star Wars, right?" And they said, "No." Luckily, Lucas re-released the film, so we were saved, but I felt old when that happened. Anyway, whenever I lectured, I always like going off on tangents. Risk of being faculty. Right, so you have to think about Reagan's old thing of trust but verify. Given that users are going to choose to trust devices too much, how do you help them figure out what's going on so if something bad starts to happen, they can stop it? Secondary requirements, being lightweight, minimizing the infrastructure. We wanted cell phones to be able to do this, which means you can't have a big footprint. And also the notion of being flexible and extensible. We didn't have all the answers for how this was going to work, and so we wanted either ourselves or other people to be able to tack on other parts later on. So the approach that we came up with was this notion of, instead of describing the interface itself, we came up with the idea of creating a template for an interface. So you as the designer would create one of these templates, and you would describe both the interface and the choices that the user could make. What the particular components were the users could choose to divide in different places, how the content could vary, and what the possibilities were for behaviors. And we actually came up with a system. We started building this before I left Georgia Tech. We came up with the acronym DIAMOND for dividing interfaces across multiple artistically annexed devices. Heather Mahaney gets credit for that. She worked very hard in coming up with an appropriate acronym. So different pieces. You had a template library that was shared across the devices. You could have things, for example, like templates for dialog boxes. So each application didn't have to reinvent the wheel for particular interfaces it wanted to use. Think of this as sort of modified MVC. So you did have the model where you had your application data and behaviors. You had the XDL composer, which was responsible for taking those templates and then, based on the user choices, coming up with the specific interface descriptions, which then would get passed to the individual devices, and they would take those descriptions and come up with a concrete interface they could render and display to the user. And in the first pass of this, we actually built this as an asymmetric tuple space. So instead of a tuple space that was sort of symmetric and both sides could see all the data, you had a notion of your personal device, which was privileged and could see all the tuple space, and then the desktop you were annexing, which could be a potentially untrustworthy device, and saw a limited amount of the tuple space here. And there were restrictions on both what information could flow this way as well as what information and commands could flow this way. So some examples we whipped up for this. So this was, for example, an email inbox on a phone. And you could choose to, wanted to forward a particular message, and you could divide that message so that you could type up a response on the annexed desktop PC, but then view the headers and the message you're responding to on the personal device, so that this public device couldn't capture the headers, so email addresses, and also couldn't necessarily see the content of what you were responding to. Calendar example. So you wanted to view your calendar on a nearby desktop. We used to joke about this was the example where the dean came up to you in the hallway and said, "I want to meet with you next week. When are you available?" And so you could show your schedule on a public display, but instead of showing exactly what you were doing, so if you had nap penciled in at noon on Tuesday, you could replace that with something that said busy. So the dean couldn't say you were napping and said, you're not really working there, give me that time. But you could then select particular events and view the actual details for them on your personal device. And then we actually built that drawing interface too, where you could draw on a tablet and view a zoomed in part of that image while viewing the actual impact of the changes that you were making on a nearby desktop display. Okay, so this was something that we started my last year or so at Georgia Tech and pushed on a bit, but didn't work on too hard before I left. So open questions about this. One of the ones that I'm really interested in is the notion of helping users understand the risks and effects of using public devices. Okay, so how do you help people figure out when they divide interfaces what the potential impact of their choices are, and then once they've divided and started to interact, what the actual impact of those choices are? Okay, this is actually something that, ironically enough, IBM is starting to care about too, because they're sort of looking at web services, and so IBM cares a lot about inappropriate access to its network systems. So they've worked really hard to have a nice VPN so that from my laptop I can access the system securely. Well, it turns out that people want to be able to access these services from outside the company just like they access Gmail. And IBM cares a little bit more about the security of its email system than Google does. Google doesn't care a lot if you get hacked for your email account because you don't work for the company. And so they're starting to think about how do you securely authenticate users and how do you balance this access to information with preserving the company's sort of corporate secrets, IBM confidential information. So there are questions about how do you help people understand the choices they're going to make and also the effect of those choices. There's also a question of how do you provide, what's the best approach to providing that translucency? So we came up with the notion of translucency to describe this. You didn't want to have transparency because that was too much information. But you didn't want to have the current opacity we have now where, for example, this device could be streaming the contents of its hard drive to China and I really wouldn't know. Unless the fan kicks on, then I look at what's chewing up so much CPU that my fan is going. From the user interface toolkit standpoint, there was this question of, creating a visible interface is not something that Visual Basic lets you do. So what are the right tools and the right abstractions to help developers build these interfaces that allow users to then pull them apart and allocate them across devices? One of the ones we also pushed on a little bit was, what was this best mechanism for connecting devices? What is the best way to say that I want to connect my cell phone to some arbitrary device and have that connection happen in a smooth way?
Hey, Jeff.
Yeah.
Quick question on that one.
Sure.
From the tool's perspective, did you ever get as far as, for example, in your email thing where you split it between the Trio and a desktop, could you move the to field from one device to the other and have it automatically generate the code for those two devices distinctly?
Yes.
That's pretty slick.
But it was incredibly cumbersome if we let you make too many divisions. That sort of gets into the, figure out what the common cases are to make those as easy as possible. And then if you really want to pull out the to field, we'll let you do it, but it's going to be kind of painful. And in that version of the tool, it was really painful. But you could do it. Okay, so sort of stepping back and summarizing here. We're moving from this model where users are working with a single personal computer, the model we have for interaction now, to this idea of interacting across a collection of heterogeneous devices. Okay? That offers both opportunities and also challenges. Okay? So the way we're phrasing it, this notion of moving toward a personal information environment, there are all sorts of fun capabilities we can think about bringing to bear for users working in these environments. And I do have the stuff that I'm doing at IBM Research right now, since most of it hasn't been filed for invention disclosures, I can't talk about. But Jimmy Lin and John Tong showed this at CSCW last week and went through the hard work of making sure corporate signed off on it. So I'll show you a little sneak peek of what I'm playing with. I have two images here. This one is from a IBM PC, and this one is from a Mac. This is actually my MacBook Pro. What they are showing is a collection of information about people, about attachments I recently received, and then files that I've recently worked with. Okay? So behind the scenes, there is basically some information gathering tools. A plugin for mail that looks at people you're emailing and people that have emailed you and pulls out their email addresses and names. There's a plugin for an instant messaging client that does the same thing for IM. The email client also pulls out information about attachments and messages you've viewed recently. And then there's a mechanism for gathering information for recently accessed files. So the recent file mechanisms on Windows and the recent file mechanisms on the Macintosh. And in the spirit of working across devices, what these two devices are doing is they're keeping track of this information for themselves, and they're sharing it across the different devices. So if you look in the parentheses behind, Thoth is actually the name of my Mac laptop. And then, being an IBM laptop, I didn't feel the need to give it an imaginative name. So IBM laptop is this thing right here. Since people for a particular device doesn't make a whole lot of sense, that is not actually tied to a particular device. It's just people you've contacted recently. The attachments are actually tagged with the device that you've received that email on. And then the recent files is tagged with the particular device that it's coming from. And what I can do with this is, if I get an email from someone on my Mac, and I then take my PC home and want to respond to that person, I actually have a simple way to initiate email to that person. I can double click on their name here, and it'll launch an email message to that person without me cutting and pasting the email between or forwarding the message to myself between those two accounts. Same sort of thing. If I get an attachment and then I want to work with it later on a different file, different machine, sorry, I actually have essentially a pointer to that file where from the other device I can double click on this thing, and behind the scenes it'll transfer that file and open it up for me. And then the same sort of thing for recent files. And you can do this in sort of proactively and automatically move files around. This is actually set so that it doesn't move files until you explicitly request them. And so you can actually see, I don't know, this is kind of small, maybe you can't see. The little gray dots for files that it doesn't currently have, because it doesn't know the file type. There's no icon there. But then once it has an icon for that particular device. So let's see, let's find something. So this is actually a PDF file that I moved over from my Mac laptop to my IBM PC so that I could print it out using the official IBM printers, which my Mac doesn't know about. Okay. So we're starting to play with sort of these services that span devices to allow you to access different types of information. We have cooler stuff too, but I haven't filed those invention disclosures. So I can't talk about it yet.
So in things like that, how do you deal with versioning and like, if I pull something over to my laptop and work on it, and then I go back to work the next day and open up that file on my desktop, and I'm like, and work on it for a while before I realize. How is all that?
I have a couple answers to that question. One is we have a leg up because it's you who's doing that. And so it's not quite as hard as the classic CSCW problem where you have multiple authors. Because it's always you, it's just on different machines. So you have a little bit of a leg up there. The other answer to that is, second answer to that is, we have mechanisms whereby we can not just transfer files, but information about those files as well. And so we can, for example, transfer the bit of information saying, you've worked on this file more recently on this other device over here. Do you want to retrieve that first, or do you want to press on and push your luck and do the hard work of synchronization later? The third answer to that is that's a hard problem. We have some answers, but it's still going to be problematic even in this situation. Sorry.
To follow on that, because it's a hard problem to do in general, but there's a question of the user
Metaphor, which is one way I have of thinking of things, is there is a truth copy, everything's in my file system, and everything else is a copy or a cache.
Right.
Versus everybody has a version, and then we have to coordinate multiple devices. You're sort of pushing towards a multiple device metaphor, as opposed to there's the real story, which is on the server, and everything else is just cache.
We actually played with both of those. The one that we're currently pushing on now is much more, there's different files in different devices. Which sort of fits a little bit with some preliminary studies we did looking at how do people actually use their devices. And what we found is that people don't have sort of a notion of a single truth and beauty. Different devices have different roles. So this is my media device, and truth and beauty for media files really belongs here. This is my work device where I write papers. Truth and beauty for work files belongs here. And so people actually wanted to have this notion of multiple centers of truth and beauty as opposed to one. But we also did some work back when I was at Georgia Tech in faculty with a machine learning professor and a databases professor where we actually played with a system we were calling Unison, which was the single unified information space you could access from any of your devices. And the problems we started running into is that it gets very difficult to do that once people start turning devices on and off. So if I can't guarantee that devices can exchange information before, use this device and use this device, if I can't guarantee that exchange information between the two, it makes it hard to do the single truth and beauty view.
Would Coda help there?
Coda would be a possibility. The other idea we played with was, in both cases, you're probably going to have your cell phone in your pocket. And so we talked about essentially having your cell phone be sort of SneakerNet++, where we could put some information to your cell phone, which was just the bit of, you've changed this file here. So that when you then got in proximity to the other device, you would say, hey, your cell phone's told me you changed that file, and you want to take steps to correct the possible mismatch before going forward. post-lunch coma. You guys all asleep?
Other questions?
Just kind of building on the stuff we've been talking about. So you said that a lot of this, or you said that one of your motivations was to make it so that people didn't have to have devices on all the time. But it seems to me like if you're having different information live on different devices, suddenly I have to have all my devices on because otherwise if I forget and say, oh, there's a version of that file on something else, but I have my laptop at home off, then I'm sunk. I can't get the new version. Whereas if they all lived on one central repository, I just had to leave that on.
Right.
And then,
Two parts of that. One is you've already got that situation now where you have different stuff on different devices. So, well, I'll caveat that a little bit. We actually looked a little bit about how people currently manage this situation. And there are a couple different approaches people do. There's the Gmail crowd, which is Gmail is my file synchronization mechanism, and I just mail all my files to myself, which is great as long as you remember to mail it to yourself, and if you don't, you're screwed. There's the everything lives on my USB flash drive, and that is my mechanism for carrying stuff around. It's just a mobile data repository, which is great right up until you lose it. And then what was the other one? Oh, there's the I give up on the problem. I'm just going to have a single laptop and refuse to acknowledge the existence of other devices, which is actually what my thesis advisor did. He just, his laptop was everything. And if you talked to him about the devices, he went la, 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 la. And so the stuff we're doing now, we've basically, we essentially agree. You do have to have a central mechanism. You don't have to put all your stuff there, but it's really helpful if you can cache stuff there. So you don't have to go the, Amazon S3 online storage route, although you can if you want to, particularly if you let users encrypt stuff, so you don't have to worry about what Amazon's doing with it. But you also need the central repository to get around some of the firewall and DHCP issues, because it's usually very easy for devices to open up outgoing connections, and it's usually very problematic to open up incoming connections to them, which is one of the reasons we got away from peer-peer-to-peer, was we ran smack dab into that and couldn't figure out an elegant way around it. But if you leverage things like, you can do this via web architecture if you want to. Google was playing with stuff, for example, Google Notebooks, where you can have an online repository of notes and images and access it from any of your devices. And then some of the stuff we're doing now, we're actually going back to the Survey model of extending instant messaging. And we're using that centralized server as essentially a coordination point among your devices.
Yeah, because the Google model of everything's a web app is great as long as you're on the web, but it's ultimately unsatisfying as soon as you hop on an airplane and can't get at your email, or if you follow that by extension, can't get the file system. And so that's what it seems like. Coda has some appeal in that, or the closest commercial approximation to Coda would be Microsoft's Exchange for email and calendar. Which gives you, it's auto-caching everything all the time, which generally seems to work pretty well.
Right, and that actually works relatively well for files. It's harder for smaller pieces of information. So one of the things we've been pushing on a little bit is this notion of different types of interaction across devices. Part of this is the file synchronization. I want to move large pieces of information around, and that information is going to be persistent, like files. They tend to live for a long amount of time. And in most cases, you don't modify your files that often. The working set of what you change is actually pretty small. And so you can do something like, Amazon's S3, just have an online repository for that information and check stuff out. Amazon S3 plus, CVS. But there's also stuff, here's where I really wish I could make an example, but I can't talk about it, where you have lightweight or transient information, or you want to issue commands across devices, where the notion of exchange is really too heavyweight. It's not something that is, data you want to be persistent, you want to keep around. It's, I want to get the stuff between these devices, between a bunch of devices right now. And I don't care about, 10 minutes from now or 15 minutes from now or 2 days from now. And in that case, something like IAM actually works better because it is much more about the transient routing of information between devices. But for stuff like file synchronization, stuff like Exchange or, Google keeps getting rumored to be doing an online storage repository. That sort of thing actually makes a lot of sense. And then there's where you get your passionate battles between all our information should be online in a centralized storage repository versus the Intel personal server will just carry all our data with us. Why would you want to do centralized repositories? Networks can go down crowds, which I occasionally engage in because it's fun.
Okay, any other questions? Thank you.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.